The first new feature I'd like to take a look at in Revit 2017 is going to be the connections, the structural connections. This is a very interesting feature, something we've been waiting for many years. As structural consultants, we don't necessarily need to create all of the fabrication details behind the steel connection, but we do need better tools to convey our design intent to the fabricator. Perhaps to convey a simple connection or a full moment connection, and to really be able to display these in 3D, not just for structural design, but also for overall coordination. So let's take a look at what the Revit can do with this new capability. So you can see here that we have a variety of connections available. There are just over 20 connections available at the moment that we can then apply to the steel frame. So you can see we have apex connections here, haunch connections, base plates, and so on. A particular interest is when you get into situations like this where we have a reinforcement bar in the model as well. And then obviously we can start to coordinate the holding down bolts with the main bars coming through to make sure there are no clashes and so on. So it does give us a much better capability to model these conditions. Before we actually start to model the connections, let's take a look at some of the settings. So you'll notice on the structure ribbon now, we have a connection command, and we also have some settings that we can go and take a look at. So what the settings do is they allow us to actually add any number of those 22 connections across into the project. So they're loaded at the moment. If I didn't want to use these, I could remove them. Yep, and then they wouldn't appear in the pull down list. As time goes on, this API will be open to third-party developers, so we can expect to see these connections become more and more comprehensive, and perhaps even an interface where we can create our own user connections. Okay, so let's have a look at now how we can add these into the model. So I'll select the connection command. In the Properties palette, from the Type selector, I'll choose, in this example, a clip angle connection. Make the selection of the members that we want to connect. And in the background, Revit will now calculate that connection. So you can see as time goes on, it will then start to build the connection, notch the member back, and so on. So here's the connection member. Let's now take a look at that. So you can see it looks pretty good. It's also actually applying all of the holes into the steel beam member as well. So I'm just going to isolate this member just so you can see what it's done. So obviously there you can see that it has physically drilled the holes, the bolt holes through the beam there. And also if we start to take a look at the notching, if we take a look at this beam here and once again isolate that element, yeah, we can see that it's put all of the notches on as well. Okay, let's have a look at the physical settings for this connection type. So to change the connections, we can simply double click. And you'll notice that this dialog box, if you've used Advanced Steel, is almost exactly the same. Now, while we're talking about Advanced Steel, this particular functionality isn't meant to replace Advanced Steel. It's supposed to be for early design. So as I say, this is aimed at structural consultants that want to convey a structural condition much earlier on in a design and don't necessarily have the requirement of generating fabrication drawings. So in here, what we're going to do is first do a code check. So you can see here, I can do a code check to Eurocodes. We can take the loading conditions directly from Robot or another analysis application. So we can take the member end forces through and design a connection based on those. Or in this simple example here, I'm going to add my own vertical load in. So in this case, let's just say it's 50. So we'll run a check. And we can see this has now passed. Let's have a look at the report. And as we take a look down through the report here, we can see things like minimum edge distance on the plates. So as well as checking for things like shear and structural conditions, it's also checking for constructability as well. Things like if the bolt is too close to the edge, that's going to be a failure, of course, and so on. If we come down further through the report here, we'll start to see the utilization. Yeah, so we've got bolt bearing verification there, and then we've got a utilization in here. We have bolt bearing on the secondary beam and so on. So in here, what I could probably do is start to remove some of those bolts. So if we go to some vertical bolt spacing in here, you can see I've got 3 bolts at the moment. So I'm going to change that to 2 bolts. Let's have a starting distance of 40 and an intermediate distance perhaps of 100. Okay, so there's the model updated automatically in there. If we go back through and recheck, now what you'll notice is the bolt spacing is now starting to fail and so on. So very, very useful functionality. Okay, so what else can we do with this? Well, let's take a look at an elevation I made earlier here. And in here, you can see that I'm starting to detail up the connections in the view here. It's worth noting that these connections will actually only show in a fine level of detail. So if I go to a medium level of detail, then we get a symbolic representation for a structural connection. If I go to a fine level of detail, then it will project the connection and show all of the settings and so on. Now, of course, we can get in and start to dimension these, which is very, very useful. So if I wanted to actually show the depth of the bolt there, very easy to get in and start to add dimensions, perhaps the size of the base plate and so on. If we now take a look at perhaps another type of 3D view, in this example here, I've created a displaced view, so we can start to show assembly procedures, the operation of how the connection goes together and out in sight and so on. So very, very good at actually conveying extra information into the Revit model. Okay, the other good thing with this, of course, is we can start to get a more accurate estimate of steel tonnage. And also from a coordination point of view, if we've modelled things like haunches and so on, that could obviously create a clash. If we've modelled it here, we'll see that clash much earlier on in the design. Okay, so all in all, very welcome new feature. The next feature I'd like to look at is going to be an improvement Autodesk have made to reinforcement. There are a number of improvements here, but the first thing we'll look at is varying range reinforcement. So you can see here that I have a tapered beam, and in this example I've already placed in some reinforcement bar. How this is working is if I select the range of reinforcement here, you'll see up on the ribbon here we now have a new icon that enables varying range rebar. So if this isn't selected, it won't follow the formwork. If it's selected, it will follow the formwork of that structural member. If I change the shape handle here, you'll see the links will now follow the tapered face there, and hence they will vary in shape. So let's have a look at how we might actually add one of these varying range rebar sets to a slab. Okay, so here you can see that we have a slab in place. What I'm going to do is start by actually adding a reinforcement bar. So in here, we'll go for H10, and we'll place our first bar here. In a sectional view, you'll see that the reinforcement bar has, of course, snapped to cover. We'll now create a range, and perhaps we'll have 300 millimeters between the rebars. And I'm going to rotate that range as well, so it actually ranges across the slab rather than down through the depth of the slab. And we'll use the shape handle here to increase the range length. So if we now go back to our level 2 plan, you'll see at the moment that if I increase the range, what Revit's doing is it's actually keeping all the bars the same length. And of course, in this example, I really require a varying range. So we can select the varying range rebar option. Okay, and you'll now notice that it's snapped to the edge cover or the side cover of the slab. And now if I arrange my bars down, you'll now see that they're following the formwork. So in this example, I'll now show the middle reinforcement bar, and I'll now add a range indicator across that. Okay, so what's quite interesting here is you'll notice that it's calling up the bars from A to S. If I select that reinforcement bar and decrease the number of bars in the range here, you'll now notice that the tag automatically updates. This is due to some of the new settings that we can set up. If I go to reinforcement settings and I go to varying rebar set, you'll notice I could number the bars individually, where each bar would have a completely different bar mark, or I can number the bars as a whole, so each bar has the same bar mark, but it will have the suffix of, in this case, A, B, C, D, E, or of course we could have suffixes as 0.1, 0.2, 0.3, and so on. To see this in a little bit more detail, let's take a look at a reinforcement schedule. So I'm going to look at the schedule for my slab. And you'll notice in this example here that we have the bar marks coming down through here. And then when I come into my varying range here, you can see I've got bar mark 49, and then we have A, B, C, D, E, F, and so on. So very nice bit of functionality there. The next feature I'd like to show is reinforcement couplers. To show this, we'll go into a 3D view. Okay, and you can see here that I have the main bars from the beam coming through, and in this example, instead of using a lap, I want to use some couplers. So up on the ribbon here, under the reinforcement panel, you'll now notice we have rebar coupler. If I select this tool, we have a number of different couplers that we can actually use. These are family files that can be completely customized, so you can edit family and create your own couplers if you require. You'll notice we have some anchors if we want to, or we have sort of standard couplers or transition couplers. In this case, I'm going to use a standard coupler. And you'll notice here, this is going to place between two rebars, or of course, if it was an anchor, we could place it just at one bar. And it does work on sets, so I can select both those sets there, and you'll see the couplers are now added in. Let's add another example of that. So you can see I have my bars on this slab here, and you'll notice here again I have a position here for some couplers, so we'll just change the size here, and again I can add those through. Let's now take a look at some rebar constraints. So in this example, we'll go directly into a sectional view in a beam. What we're going to do now is actually place some bars in bundles at the bottom of the beam here. Now, this task was always quite difficult in previous releases because you couldn't really snap the bars together. They weren't constrained. So now, if I select the beam, we'll go to the rebar command. You'll notice here I have an icon here called constrained placement. If it's off, you'll notice that this bar behaves like it would in previous releases, so it's not really locking onto any of these bars here. Yes, it will snap to the link, but it won't snap to these bars. So if I choose constrained placement, you'll now notice that we have a slightly different behavior where this bar is now locking on to the bottom bar here. Yeah. So what I can now do is place these bars in like so. One of the nice things with this is if I then change the bar size, so if I go down to a 10, you can see that it holds those constraints. So that is a huge improvement over previous releases there. Also, the way we actually edit constraints has changed as well. So if I now select this rebar here, you'll see that I've now got edit constraints. And if I choose this, in previous releases, you would have a dialog box and you would have to try and locate the bar that you wanted to edit the constraints on. Now all we do here is you just simply pick the bar like this, and you can see it has a very simple dimension in here, and we can just type in the constraint we're after. So in this case it might be 60, and you can see it very simply moves that bar. When we're done, if we want to finish, we just hit the green tick and that's now done. Obviously there you can move across to any other bar and edit those constraints and then see the relative dimensions attached to it. Yeah. So in this case, again, we might want to go to 60. Okay, so much easier way of editing the constraints. The final reinforcement feature is going to be bent fabrics. So here you can see that we have a slab and we have this depression or recess inside the slab. If I create a sectional view through that, so if we go to section here, what we might need to do is actually put some mesh and actually bend the mesh around the top face of the slab. So now you'll notice we can do this. We can go to the mesh command, so fabric sheet in this example here, and the new function is bend sketch. So I can select this. We can select our slab in this case, and we can now sketch where we want the bend sheet to go. Perhaps something like this. Now, even if your sketch is too long, the sheet will obviously only bend to its length, its sheet length. So you can see here, obviously, the sheet length is a little bit shorter than the one I've sketched. But the key thing there is you can now see that we've been able to very easily bend that fabric round. And of course, I can go back and edit the sketch whenever I like, make some changes, and the fabric updates. If we take a look in 3D, again, we can get a representation of that bent fabric through there. And of course, we can change the sheet size once we've done that, and everything will update accordingly. Whilst this next feature isn't specifically related to some structural enhancements, nevertheless, it's very, very useful. Something that's always been slightly tricky in the past is the management of reference planes. We all use reference planes in the family editor or in the project to locate specific members. Sometimes we'll use them to set out roofs, other times it might be just to set out structural framing, that sort of thing. And really it'd be a nice idea if we could identify reference planes' use by colours and so on, and be able to switch certain things off. So we can now actually do that. If I go into Manage and Object Styles, switch to the Annotation Objects and search for reference planes, you'll now see here that we can actually create subcategories of a reference plane. So I'm going to create a new one in here, and I'm going to call this one Beams, and another new one here, and perhaps this one will be Roof. We can then set different colours for these, so perhaps for beam setting out I'm going to use blue, and I want to use the aligning line, and for my roof setting out I'm going to use red, and again I'll use the aligning line again. So how does that work? Well, what we can now do is we can select an existing reference plane, such as this one here perhaps, and you'll notice I can very easily change the subcategory. Yep, so you now notice that one's appearing blue. If I create a new reference plane, like this, then obviously I can change that one now to roof setting out, and you can now see I've got those 3 different types. Obviously, when I'm generating new reference planes, I can go to the reference plane command and simply choose my subcategory prior to drawing the plane. So let's draw another one on roof. Big advantage here, of course, is if I now want to switch off a particular subcategory, I can just go into Visibility Graphics in the usual way. We can go to Annotation Categories, find Reference Planes, and of course in here, if I wanted to, I could now very easily just switch off the reference planes relating to the roof setting out, and you can see the red reference planes disappear. So very, very useful change. Okay, so in this section, we're going to take a look at some productivity changes that have happened, namely to structural columns, to foundations, and also to slabs. So let's now start by taking a look at the column improvements. So one of the key things is if I select this column at the moment, you'll notice the issue is that it's been modelled from the foundation all the way to the top of the column. Ideally, what I want to do here is have the function of being able to split that column. This causes us a number of problems. If, after analysis, it's deemed that the structural column needs to reduce in section size on some of these upper levels, then it means that I've got to remodel those. Also, some analysis products will require a node at each level. All of these requirements really need us to be able to split that column. So if I go to the south elevation, up on the Modify ribbon here, I have the standard split element command. I'm going to select this, move over my structural column, and you'll now notice that I can very easily split the column where I like. Now, in this case, I'm actually splitting it at levels, but of course I could split that wherever I wanted. So if I wanted a splice, perhaps here, yeah, I could split that quite easily, and there's the splice. Of course, that's also split it in the analytical model as well. So you'll now notice that I have these separate columns here for analysis purposes, which again is very, very useful. Okay, let's now have a look at some other changes. So what we'll look at here is a global change that's been made to floors and also foundations. And we now have the ability to find the levels at the top and bottom of these elements, both at project and survey point level. So let's start off by having a look at some tagging. If I go to perhaps the level 3 plan and choose annotate and tag by category, what's going to happen here is I'm going to put a leader on and a free end, and you'll notice here that I have a tag now that's actually reading off the slab thickness. So I'm going to go ahead and place this in. Okay, we'll just get rid of that tag, the leader, as I don't require that anymore. Now, what's actually happening is that's reading the true slab thickness. Now in this case, just to highlight this issue, if I select the slab, you'll notice I've labelled it up incorrectly, and it currently says RC slab 250. You'll notice that the height offset here is 175. If I edit the type, you can see the default thickness is 175. If I come along and change it, so I'm going to make this now 225, instantly now you can see that my tag updates. So that is very, very useful. So the ability to pull out the actual physical thickness of things like floors and foundations and then apply those as tags. Let's have a look at another example of that. So what I'm going to do here is change it to another type of tag. And in this case now, what I'm actually doing is putting off the level of this slab here. Now, the level is actually taken from the survey point, which again is very, very useful. So bear in mind here, I'm actually on the level 3 slab. If I go to the south elevation and we take a look, you can see that the level there is 29 meters. So obviously if I go back in here, including the slab thickness, it's 29.175. So again, very, very useful. This data can also be exposed into things like schedules as well. So if I go and have a look at my slab schedule, you'll now notice that I can obviously incorporate those slab thicknesses in here. Clearly you'll see they've updated to 225 from 175. I have my level in here, and I actually have my physical level again from the survey point in here. If I go and show you some of the fields here, this is elevation at top survey. What I could do is just take elevation at top as well, and you'll notice I have the option of doing the soffit of the slab here, which is bottom. So now you can see that I have the level from the project base point and also the level from the survey point. So very, very useful. In a very similar theme, we can do exactly the same for foundations. So you'll notice here that I've scheduled out a pile cap and the 2 piles inside the pile cap. So again here, I have from the survey point the top of the pile and also the toe of the pile as well, again from that survey. So some small productivity changes there, but very, very useful.